Yes, perfect. So my talk is about ReasonML. It's called Type-Safe Functional React with ReasonML. And if you don't know what ReasonML is, well, that's the point of the talk. I'm trying to give a simple introduction to ReasonML, what it is, what it does, why you should use it. And yeah, that's about it. So actually, I had planned to start a timer because I'm not really good at managing time. Yeah, all good. So my name is Guillaume, and I work as a Scala developer for a consulting company. And I love functional programming and playing strategy games and riding roller coasters. And since I love functional programming, and especially in statically typed languages, I have started to code in ReasonML about a year ago on a recommendation from a colleague. And I will attempt to sum up some of the most interesting features of ReasonML in this talk. So what is ReasonML? ReasonML is a programming language, but it's not an entirely new language. In fact, it is nearly equivalent to another language, which is OCaml. OCaml is not a very famous language, at least not in the mainstream sense like JavaScript is, but it's a very robust one. So OCaml has been around for several decades now. It is born in the French National Research Center for Computer Science and Artificial Intelligence. And it's a functional language with a strong type system. And Reason is a new language and a new toolchain that builds on the strong foundation of OCaml. It has all the same features that OCaml has, but it also has a syntax that makes it easier for JavaScript developers to pick up the language. So it's OCaml with easier adoption from people coming from a JavaScript background. And it has also, as part of the toolchain, a compiler called BuckleScript. And BuckleScript is a tool we use to compile ReasonML code to JavaScript that you can run in your browser. So you can write native applications with ReasonML, but you can also write web applications. And I think most people use it to write web applications. Some of the reasons that ReasonML is so useful and so appreciated is its easy interoperability with JavaScript and its speed. It has very fast compilation time and also a very clean JavaScript output, so it also runs well in the browser. All right, I won't have enough time to show all the features of the language, but I will quote this tool by Jordan Walk, the original author of React and ReasonML, and he said in a tool called React to the Future that he saw in ReasonML a way of unlocking a more ambitious future for UI development. And ReasonML, at least in the mind of Jordan Walk, is React as first intended, because the first prototype of React, before it was open sourced by Facebook, was actually implemented in standard ML, so like the ancestor of ReasonML, an older language that is part of the same family, not in JavaScript. So React was originally meant to be a functional declarative library for UI development that was also type safe, and it shifted to become the library many of us know. But with ReasonML, we now have the tool to build React applications in the way that Jordan Walk and the original creators of React thought about when they started working on the project. So that's pretty cool. In this talk, I will be talking specifically about setting up a React application. I will show JSX support and also CSS and JS support. We will talk about modules, records, variants, pattern matching. All these features are specific to ReasonML and they enable type safety. and the ability to build more robust applications. And I will also talk about the more functional aspect of the language, so functional composition and theory. All right, let's do this. So we talked about ReasonML, which is the language, and BoggleScript, which is a compiler. One essential part that we haven't talked about yet is ReasonReact, which is the official binding for ReasonML, the official React binding for ReasonML. It has 100% feature parity with vanilla React. So what it means is anything you can do in React, you can do in ReasonReact, but with types on top of it. And as part of the ReasonReact ecosystem, you also have support for CSS and GS via a binding to emotion, snapshot testing via a binding to the Jest testing library, and also component development via Storybook. Some of the most common tools we use in UI development in the vanilla React world, we can use in ReasonML, and there are already very good bindings to these libraries, so you don't have to write the bindings from scratch. And spinning up a ReasonReact application is very easy. You just have to install a tool that will generate the project for you. So this project is called Spin. And once you have Spin installed on your system, you can just type Spin new, the name of your app, and the name of the template that you wish to use, which in that case is BS React. BS stands for BoggleScript in the ReasonML world, not the BS that you would think of. And then you are good. You just start the app and start coding. All right. So the rest of the talk is essentially a demo. So this is the last slide. So let me show the demo. All right. So here in VS Code, we have a ReasonML application, and I will start it right now. So there are several ways of starting the application. You need to start two distinct processes. The BoggleScript process, which will compile your ReasonML sources to JavaScript, and the Webpack process, which will bundle your JavaScript and CSS files together to create the final bundle and start the web server. And you can start these two processes concurrently, but most of the time you will want to start them separately, because that way the output of the ReasonML process is nicer. And as I will show later in the talk, the ReasonML output, especially when you have compile errors, is very nice and very useful. So you don't want to miss that. So the first step is to start the Webpack process. So what was it again? Webpack, like that. And then in another terminal, I will start the BoggleScript process. So here we go. And you can see that the compiling is very, very fast. It actually compiled the application in like less than a second, 15 milliseconds actually. And this is a cold start. It's not even the reloading part. So when I say that ReasonML has fast compile time, it has very fast compile time. The main bottleneck that you will have when starting the application is the Webpack part, not the BoggleScript part. And so here is the application. And I thought that the best way of showcasing how you could write React applications with ReasonML would be to write a partial recreation of the QueerJS website. So it has the same design characteristic, but of course, not all the content. And this is a React application, and I will walk you through some of its features. So the first page is the home page, and it looks something like, let me find it. It looks something like this. So, oops. All right. So all your sources, they live in the src folder, and it's not like in JavaScript or TypeScript applications when you use JavaScript modules, where you import a module using its path on the file system. Here we don't have any reference to the location of the file on the file system. It's like everything that you see here in the src folder will be picked up by BogardScript and will be compiled. And when you open a module, it will find the module for you wherever it lives. So the first page that I want to show is the home page, and it's a very simple React component. So if you're already sort of familiar with React, you can guess what this does. It looks like standard React, apart from some differences. When you create a component with Reason React, you have to put this little annotation here, the @React component, to tell it that this is a React component. And then you can write standard JSX, so elements that look like HTML, and you put your content in there. And the only thing that is very different from vanilla React is that you can't just put text inside of nodes like you would in other in TypeScript or JavaScript. This gives immediately a compile error. You need to cast it specifically to a React string element. The reason for that is that we live in a statically typed language, and it doesn't have implicit conversions between text nodes and React elements. So you have to convert the text explicitly to a React string, to a React element through a method that's called React string. It's the only main difference. The rest is regular React. And so this page is referenced somewhere in the app module, which is, sorry for the funky zoom, which is the entry point of our application where the router lives, and we'll talk a little bit about the router later. So that's the home page, and it's a static home page with static content. But the demo page is a little bit more interesting. So it's a partial recreation of the meetup page that is on the QueerJS website, with all the faces of the awesome speakers for today's meetup and the organizers. It looks like the original page, again with less content. And I also added a little functionality, which is the ability to add a speaker, because I wanted to showcase how you could manage state in ReasonML applications, and you will see that they work just like vanilla React with state hooks and that sort of things. So if I type the name of a speaker, like an awesome speaker, and I add the speaker, it creates a new element in the list with the name that I have provided. Again, pretty straightforward app, but I will show you how the component works. So back to the code. This page is called page_meetup. And here you can see that I have a list of all the people on the page, all the speakers and all the organizers. And this list is actually statically typed, although it does not quite feel like it. The great thing about ReasonML is that it's a statically typed language, so it won't let you mix everything up. But at the same time, it has a very powerful inference system. It can infer types, so you don't have to put them explicitly. What that means is that when I define an organizer variable with data associated to it, I can say to the compiler that this is a list of person. Actually, it's person.t, the name of the type, and it should work, although it doesn't, which is not great. Anyway, it doesn't change the point. So you can have this explicit annotation of the type of the variable, but you don't need to provide this explicit annotation simply because the compiler can guess it for you based on the shape of your data. So here you see that we have an open statement, which you can think of like an import. So it takes functions and types that are defined in another module and brings them into the current scope. And if I remove that statement, then I have immediately compiled errors because it doesn't know about a record field called name. So this thing that looks like a JavaScript object with keys and values is a record. And to be able to define a record, you need to define a type for that record. And you can't have untyped records. So in the types module is where the record lives. And and this thing, the type T equal with the braces and then the keys and the types is the shape of my record. So here it says that the type called person.t is a type that is a record, and it must have the keys name, image, and Twitter username, where name is a string and image is an option of URL and Twitter username is an option of string. And we'll get into option later, but you can think of them like ReasonML doesn't have undefined values and it doesn't have nodes either, but it has options, which are these structures that allow you to model optional fields, like the name suggests. And as long as I have this type defined and present in my scope, ReasonML will find it and will guess that this organizer's list is a list of person. So I don't have to put the type explicitly. For the rest of the component, this is pretty standard React. So we have standard elements such as headings and paragraphs, and also custom elements that I have defined elsewhere, such as this custom grid element. And then we have our organizers and speakers list, which are mapped over and passed to a function that will render the singular person component. So I have a component that renders the image of a speaker along with the image of a person along with their name. And I map over the list and it renders a list of people. So this is what this line does. Okay, so what's next? So the speaker component, or the person component, it's called, is defined here. And here we have an example of CSS and GS using the BS CSS module, which is a type-safe binding to emotion. And here we have all the standard CSS properties that you might expect, but these are all defined in ReasonML, and these are all type safe. And what this means is you can't, for example, take a property like display and pass it something that it doesn't expect, like a number. So display 10 doesn't mean anything. And if I do that, I get immediately a nice colorful error that says on this line, the line 22, you have a call to display and you pass it an int, but what I wanted instead is a type that looks like this. So what this means is you can pass me any of these elements, but not an int. So you can pass me grid, you can pass me flex, you can pass me block, but you can't pass me an int. All right, so let's put it the way it were. So this is CSS and GS, and it works. It is rather straightforward, and it's entirely type safe. And the rest of the component is very simple. It's just a div with some classes, and then we extract the URL from the image of the person that we want to render, and we use that URL as the background image for our div component. The get image function is one that extracts extracts the image from the person according to some rules. So we call that a person can have an optional image, but also an optional Twitter username. And what we will do with that is, if that person has an image, then we use that URL, and if they haven't, then we use the image from their Twitter username, and if they haven't got a Twitter username, we use a default image, which is a picture of a dog. And this is why when we add a speaker without an image using the form, it adds this picture of a dog. All right. Before we dig into this part here, which can feel a little bit cryptic if you haven't seen ReasonML before, there are other things, simpler things that I want to show, specifically back to the meetup page, the way we handle state. So if you have worked with React before, you know about hooks. Hooks are used to manage states and effects in functional components. And in ReasonML, you only have functional components. You don't have classes because the language doesn't have classes, but you have all the hooks that you would expect. And here we have two calls to the React useState method, and these calls allow us to keep in the state of the component the list of speakers and whether or not the form is open. And the rest of it is very similar to what you would find on vanilla React. We have a form component which is defined elsewhere, and this form component exposes some several props. So the state of the form, whether it is open or not, is controlled from outside. And then the component exposes some callbacks on submit and on toggle that allow us to know when the user has clicked on the close button or the submit button. All right. Among the last things that I would like to show, I've talked a little bit about the type safety parts of ReasonML, but I would like to show also another cool feature, which is variance and pattern matching. And actually, they are used in the person component. So I haven't talked about this part here yet. In this part, we define a custom type, which is a type size, which is either small or big. So you can think of it like an enum. And then we use that enum to transform it into a value of pixels. So if the size of if the size that I give to my component is small, then the size of the image will be 100 pixels. And if the size of the component is big, then the size of the image will be 240 pixels. And we have defined this custom type, and this custom type allows us to make sure that I can't pass garbage to my component. So here you can see that the component accepts two props, a person prop, which is the type person that we've seen earlier, and a size prop, which is either big or small. And it passes it to a function that generates a class for that component. And if you look at that function, the function defines several properties such as background image and background size, but also the actual size of the image. And it's all type safe. And one very cool feature is that in that particular statement, which we call a pattern matching statement, which you can think of as a switch on steroids, it's like a switch instant in most languages, but it can also do so much more. When you delete a branch, you will get an error immediately, a warning telling you that for some cases this code may fail. So I have forgotten I have handled the case where size was small, but if size is big, then the code will fail at runtime. So that the code doesn't fail at runtime, the compiler tells you before that you have forgotten one particular case. So this is cool. And this is one of the features that help us deliver more robust code in production. I'm running out of time, so I won't cover everything, but now that you know a little bit about variants, so these things like these enums are called variants, and about pattern matching, the last things that I want to show are routing. So the routing, sorry. This lives in the entry point of the application. This is where we bind URLs to pages. And here we see our friend, the pattern matching. So the way routers work in ReasonML is you make a call to the Reason React router, and it gives you the current URL in the form of a list. And each element of the list is a segment of the URL. So in the case where there are no segments, it means you are in the root of your application, and you can render the home page. And if you have, and if you are on the /meetup page, then you render the page _ meetup. And for every other case, this underscore here is like a wildcard. For every other case, we render a page called not found. And you can do more advanced things, like if you want to have path parameters, then you could have something like speakers, a comma, and then some ID. And on the right-hand side of the pattern matching, you can retrieve your ID in the form of a string. So that means you can render some components like a speaker component, whatever, and pass it an ID like this. So it's very, very simple to implement routing in Reason React applications. It's already past time, so there are other examples in the project, and if you want to dive in, I will put all the code and the slides on GitHub right after the talk. So feel free to explore for yourself, and I will also answer any questions you might have on ReasonML. The last thing that I want to finish with is it production ready? And the short answer that I can give is, of course it is, because I use it. No, but more seriously, I believe that ReasonML is production ready, and that it enables React developer to deliver more robust applications. It is built on a very strong foundation, a language that has been around for several years, and that has a very robust type system. And it is also used in production by Facebook, by Messenger, by all sorts of companies. They actually have a list of companies using ReasonML in production on their website. And they already have bindings for all the libraries you know and love, such as React, such as Emotion, such as Storybook. And one of the things is that if it doesn't have a binding for a particular library that you might want to use, it's very easy to define your own bindings. And you can also generate bindings automatically for that library based on their TypeScript binding. So if there is a library that doesn't exist in the ReasonML ecosystem, but it has bindings for TypeScript, you can directly generate bindings for ReasonML based on the TypeScript bindings. So it makes it very easy to adopt ReasonML. It looks like vanilla JSX, sort of. It has all the type safety that you would expect, but without the burden of writing the types explicitly. And it has all the libraries that you already know and love. And if it doesn't have them, then defining bindings is pretty straightforward. All right, so I hope you've enjoyed the talk. Thank you for having me again. And if you want to keep in touch, I'm available on Twitter. I'm available on the QueerJS Discord to discuss about this particular talk and any questions you might have. And sorry for taking up a little bit longer than I'm losing my words. A little bit longer than I should have. I hope that's okay, and I hope you enjoyed the talk.